Welcome to today's webinar brought to you by Couchbase, Cube, and Astronomer. I'm Stephen Fagg, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Building Modern Data Apps, Choosing the Right Foundation and Tools. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Now, to introduce our speakers for today, we're very excited to have with us Mark Gamble, Director of Product and Solutions Marketing at Couchbase, Artyom Kidanov, CEO and co-founder of Cube, and Stephen Hillian, Senior Vice President, Data and AI at Astronomer. So each speaker today is going to give a quick presentation, and then we're going to dive into a group discussion. So without further ado, I'm going to pass the event over to Mark to get us started. Welcome to the broadcast, Mark.
Great. Thank you, Stephen. Hi, everyone. Mark here. Great to be back with DBTA today to talk about building modern data apps and choosing the right foundation and tools to do so. As a database vendor in the panel, I'll, of course, focus on operational data and that processing side of things. And talk about it in the context of AI-powered apps that run from cloud to edge. But as I dive in, first, I'd like to turn to some accolades for Couchbase. We're really honored to have been voted tops in 3 database categories in this year's DBTA Reader's Choice Awards. We're recognized as Best IoT Solution for the 2nd year in a row. Super proud of that. We tied for Best Vector Database, and we were finalists for Best NoSQL Database. So we're super proud of this recognition from your vast community of readers, Stephen. We look forward to being in the winner's circle again in next year's awards. But now I want to dive into some of the reasons for this recognition. And this slide kind of encapsulates the end goal for our customers, the types of apps that they want to build and that they're using Couchbase to help facilitate. And they want to produce really applications that adapt themselves to individual users because, that's what keeps people using them. And by adaptive, we mean apps that are, hyper personal, that feel like interacting with a friend or trusted advisor. They're in context, but they present relevant options. They're driven by trustworthy data and can guarantee, accuracy. And they operate in real time and work everywhere, right? These are the penultimate goals. And by working everywhere, we mean with or without internet as well. And Gen AI is really propelling expectations, for this type of experience within applications. So how do we actually facilitate this? Well, we serve as the operational data layer for these apps and integrate directly with the other layers and artificial intelligence. So Couchbase provides a cloud-native NoSQL database that's used to power gigantic applications like those at LinkedIn or Tesco, Comcast, Amadeus, United Airlines. The list kind of goes on of big household name enterprise customers who use us to power their critical applications. And they do so because Couchbase is multi-purpose. And this means it's a combination of database capabilities. First, processing of key value information in memory. This is for making websites and logins hyperfast, for example. And second, the distributed storage of JSON document-based data for scale and resilience and development flexibility. And to this, we add support for vector search, full text search, eventing, columnar analytics, containerization, mobile synchronization. These are all data access patterns that our customers no longer have to bolt together from a bunch of bespoke different technologies. They get it all from one platform. And Couchbase supports relational constructs like SQL queries and ACID transactions. These are typically not found in a document database, right? And so developers can use their existing SQL skills. And when we look at the deployment layer, customers can choose to let us do the driving, use Capella, that's our hosted managed database as a service, or they can choose to manage their own Couchbase deployments in the cloud or on-prem. And this represents sort of Couchbase in a nutshell. And I specifically focus on our edge capabilities, which is facilitated with Couchbase Mobile. And this is a product stack made of 3 foundational components. First, it's Couchbase Capella. That's the flagship distributed NoSQL document database I just talked about. And then there's also a Couchbase Lite. So this is the embeddable version of Couchbase for mobile and custom embedded devices. And then what sits in between is app services. And this is responsible for secure data synchronization, routing, and access control between the mobile clients and server tiers. And these can be deployed 2 ways, fully managed with Couchbase Capella or self-managed. And that's where, again, customers can install Couchbase themselves on public or private clouds, on Cloud Edge service, or on-prem. So I want to talk about kind of those 2 ends of the stack. There's on-device data processing, there's in the cloud data processing and synchronization. And we support AI at both of those ends of the spectrum, right? On the server side, our Capella Database as a Service offers the Capella Columnar service. This is essentially a columnar data store for running complex analytics queries against operational data without any impact to the operational workloads. And you also don't even have to move data into a separate repository for analysis. It's all streamed in via Kafka for real-time operational analytics. And it also has the ability to call fully trained ML models by supporting user-defined functions. And then we also, in the cloud layer, support vector search. And this enables similarity search, semantic search, all for better response precision for things like recommendation apps. And it also enables retrieval augmented generation, or RAG capabilities, for those familiar with kind of the concepts around LLMs. And this is a technique to make LLM responses more contextual and accurate. But also on device, right? The embedded database that runs at the edge also has AI capabilities built right in. Couchbase Lite has a feature called the Predictive Query API, which is used to call trained mobile ML models at the edge, using app data stored locally in Couchbase Lite. And this makes the experience fast and always in context, even when offline. And this database on device also supports vector search, right? And so this brings all of the vector search benefits I just mentioned down to the edge. And that makes searches super fast, even without the internet. So the ability to power vector search on device is really a unique differentiator for Couchbase, because other databases typically only offer vector search in the cloud, where it's dependent on the internet and thus rendered unusable if there's no internet connectivity. So when we consider AI capabilities in Couchbase and apply them to that stack across the edge computing architecture, we see that Couchbase processes data and AI in the cloud, at the edge, and even on device. And that brings the scale to handle the massive amounts of data required for AI, and the edge capabilities for the immediacy to make it effective, even when completely offline. Some use cases, I mean, they run the gamut, right? We're a database, so we're agnostic when it comes to what types of use cases we support. We support them all, but the ones that are emerging from our customers are types like these. Retail, cloud-to-edge data processing capabilities in retail can be used to enhance checkout and item lookup processes with things like AI-based image recognition. And in gaming, the addition in addition to this need for speed and resilience, we're also seeing this phenomena where gaming development studios want to enhance features of their non-player characters, the NPCs, make them behave more naturally, leveraging LLMs. And of course, you need immediate real-time data to make those interactions in context. And in travel, cruise lines represent a giant edge when they're at sea, right? Where edge data and AI processing allows for a really fast and reliable experience for passengers and crews using apps on board. And these are just a few use cases that are enabled by this concept, this notion of cloud edge data and AI processing facilitated by Couchbase. So in closing, just want to mention a recent customer of ours, Quantic. This is a point of sale system vendor that provides those checkout kiosk devices that we see. They're ubiquitous in retails of every size now. Retailers are using these. And they provide the app that runs on these devices. And part of their value proposition is that they provide the highest guarantees of speed and availability because their app leverages on-device data processing with Couchbase. And this means internet slowness and outages and disruptions, they just don't impact the checkout process. And their customers can continue to run business thanks to Couchbase, even in the face of internet outages. So just one example. All right, so I promised I'd try and stick to 5 to 7 minutes. So hopefully I've been able to do that. And I'm really pleased now to turn over the microphone to Artyom, the CEO and co-founder of Cube. So Artyom, take it away.
Thank you, Mark. Thank you. It's good to meet you all. My name is Artyom. I'm co-founder and CEO at a company called Cube. My background is in data engineering, so I built Cube as an open source project in 2019. And then in 2020, my co-founder and I, we built a company around it. So Cube is an open source technology. It's been around since 2019 for 5 years. You can go on GitHub to find it. We have a big Slack community with a lot of data engineers, developers using it. But I will talk today what it is essentially that we call a universal semantic layer and why I built Cube in the first place. So when we think about the data stack and what was the evolution of a data stack in maybe last 25, 30 years. So if we would look back 25 years ago, we would see mostly monolithic data stacks with vendors like Oracle, IBM, SAP, Microsoft to some extent, kind of selling one big solutions of that sort of like a data and analytics stacks really that were doing a lot of things from ingestion, transformation, data prepping, wrangling, down to visualization, BI tools, and SQL Warehouse was always a part of that. And semantic layer, or some people would call it cubing technology, like OLAP cubes, how you would build all these multidimensional data models and then use these data models in analysis, right? Like if you want to do like Excel Power Pivot, or you need to build a line chart, a bar chart in a BI tool, and the end user needs to drag and drop a metric, maybe revenue quarter over quarter. The system needs to know how to translate that high level metric into the set of underlying queries to the storage layer, essentially. It could be SQL queries, right? It could be multiple SQL queries that needs to be executed and to retrieve data from specific place and kind of run some post-aggregated calculation and then display this value. So that was a state of things, like everything was coupled as a single solution. What was happening about 20, 25 years ago, like, and maybe it really started 15 years ago, is like decoupling of all this data stack. So we started to see a separate vendors in a separate categories. The cloud data warehouse, it's its own huge vendor right now with Snowflake, Databricks, BigQuery. The transformation ETL market is its own category. Even transformations within the ETL is becoming its own vendor with companies like dbt or Coalesce. And BIs obviously started to become, I would say, less intelligent, more like a thinner layer, more like a visualization layer. But one thing they still remain at the BI layer is data modeling. So in a modern stack, you would have a Snowflake, and on top of Snowflake or BigQuery, you would put a lot of BI tools, such as Looker, Tableau, ThoughtSpot, and some other BI tools that would do a direct query against these tools, right? Sometimes you can use an export or combination of extracts and direct queries. But the data modeling piece or cubing piece, or now how we call it the semantic layer piece, is being embedded inside these tools. Like you have something in Looker with LookML, you have something in Tableau with calculated fields or LOEDs calculations, and then in every BI tool you have a semantic layer right now. So the problem is that why we started Cube is that I started to see this data models being really spread across all of these different tools. So you have a semantic layer that effectively lives inside a Looker. You have a semantic layer, some sort of like in a different version that lives at just a set of LOD calculations in Tableau, and then you have just a bunch of Python script that process data and export them as like Excel files just to give to finance or some other team. So this data modeling or cubing technology that it's used to be a single sort of like a place inside this big monolith application started to kind of break down and spread across multiple different places. And it makes data governance really hard. So it makes managing and making sure that the data is consistent and accurate across all of these tools really hard. In engineering, you have this idea of dry, right? Do not repeat yourself. So that's essentially this problem. We're repeating ourselves with all this data modeling, semantic modeling, calculations happening in multiple places. So idea behind Cube, when I started it, and the whole idea behind universal semantic layer is to apply dry principle to the data stack on scale, right? So instead of doing lookml, instead of doing LOD calculations or Python scripts, we take out all of the data modeling, we put it into one place, which is universal semantic layer, and then we run it on top of cloud data warehouse. So it's sort of like coming back to the original architecture in some extent, where we have a storage layer and then we have a cubing technology, right? Like a modern cubing technology that allows you to build multidimensional cubes with measures, dimensions, and then use this data model across all of these different data visualization, data consumption tools. So if you would think about Cube from a product perspective, what does it mean, right? Like being able to build data models and use this data model across all of these tools. We usually talk about Cube as a product based on 4 pillars. The one pillar is data modeling. That's essentially where you can build cubes. You can build different slices of cubes with measures, dimensions, build all different types of the metrics, time intelligence metrics, all of that stuff that people do with MDAX, for example, right? Like we support that as well. And it's all code first. So I believe a lot in applying software engineering best practices to code management, and that's one of the sort of philosophies of our companies. We wanted to make sure that we can use all the principles that were developed by software engineers over decades and apply them to data management. So like version control, collaboration, CI/CD, all of that. So data model is just essentially a set of YAML files. And then on top of this, we have security engine with permission model, policies model. And then on top of that, we have a caching, because in many cases, you really want to cache the data model. You don't want to go to Snowflake all the time. And then finally, we have APIs. It's essentially MDAX, DAX, SQL, REST, GraphQL API. So you can deploy these data models once you have them to all the downstream data visualization and data consumption tools. And that's Cube. You can check out us on GitHub. It's open source. Our cloud product is available on cube.dev as well. And that's all I have for today. Thank you, everyone. And next, I wanted to pass it to Steven.
Great. Thanks, Artyom. Interesting stuff. Maybe I'll focus a little bit on how you bring all of these things together, right? So from the database, well, from the source data to your database, to Artyom's queries and cubes, and that semantic layer through to predictive models, and ultimately to building applications. How do you coordinate all of these steps? How do you get the data to the application to build a data-driven application in the first place? That's really where Astronomer focuses with our cloud platform Astro, which is a managed service for Apache Airflow, the enormously popular open source project. Airflow was built by Airbnb about 10 years ago to manage and coordinate all of their data pipelines. If you think of Airbnb as essentially one big application for planning your vacation, that's one big application that needs a lot of data for it to deliver what it needs to deliver. And so that's a lot of coordination of data ingestion, analytics, models to power their applications. So they built that framework to coordinate of that. It grew bigger than they ever expected. They open sourced it, donated it to the Apache Software Foundation. Now it's up to, actually, these slides get old very quickly, up to 30 million downloads a month at this point. Astronomer is the commercial developer of Apache Airflow. We make about 50% of the thousands of commits that go into the project. And as I mentioned, we have a managed service for running Airflow if you don't want to have to manage the complexity of that yourself, especially if you're running it across different teams for your data engineers, data scientists, and application developers. So in a nutshell, that's what Astronomer does. Even boiling it down further, we're really on a mission to deliver data to your applications. Think of us as the FedEx for data, if you like. And you can see some examples of our customers there. They really span from finance, manufacturing, healthcare, retail, and so on. It's a mature platform. Let's talk a little bit more about what it really does in a little bit more depth. So it's not a surprise to anybody who's on this presentation or who's listening in that businesses these days depend critically on data, whether that's for producing applications or predictive models, or dashboards, reports, key metrics, and so on. That's usually a pretty complex process where you're ingesting data from many different sources, from Salesforce to applications, to marketing applications, to phones, edge devices, and so on. And so coordinating that, cleansing that data, getting it transformed, ultimately feeding that into reports or into applications or generating features for predictive models, that requires a lot of coordination. So that's hard to do just from the get-go, and then actually to run that in production in a way that's completely reliable so that your data products are as reliable as the rest of your products, is really where Airflow and Astronomer comes to play. Here's some examples. There's some classic examples from analytics and reporting. So BAM, a major investment house, uses us to create dashboards that help to influence the trading and investment decisions. But then even more operational stuff like FanDuel, for example, the popular sports gaming site that uses this for some critical operational processes, including how they define the parameters for all of the betting that happens within their application, as well as regulatory reports that they have to deliver, otherwise they're in trouble. Really thinking about end user applications, Symphony AI produces analytics that help major retailers determine the right pricing or the positioning on the shelf in your supermarket. The product they deliver is analytical applications powered by data, and they couldn't use that without that data getting delivered reliably and efficiently with Airflow. Fair is one of the world's largest B2B marketplaces. They use us for generative AI and ML ops in order to make sure that the product searches that people do, that wholesalers do to understand which products they should be merchandising and selling, that's really fundamental to their business. Again, like Symphony, it almost is their business, and so data is the thing that powers those applications through advanced hybrid searches using the sort of technologies that you see in generative AI, in vector databases, in predictive models for product recommendations. All those powered by Astro. I also think it's fun to talk about what we do at Astronomer ourselves. We use our own product for building data applications. So for example, here on the top left, you see some of the dashboards that we use for monitoring how healthy the community is doing, recent meetups and conferences and so on in the Airflow community. On the top right, we generate metrics and real-time insights that our customers use to monitor the health of their data pipelines. And so we're using our own data pipelines to help our customers manage their data pipelines, kind of meta. And then in terms of generative AI applications, we use Airflow to gather data from many different sources to power conversational chatbots to help you ask questions about Airflow. You can go to ask.astronomer.io if you have questions. If you want to get a more in-depth description of what Airflow is used for or how it can be applied for generative AI, you can type that in and get an answer back. We also use generative AI, again, powered by the masses of data that we've collected over the years, to help provide our customers with convenient log summaries. When things do go wrong with their data pipelines, can we provide them with pointers to how to make that easier? Stepping back a little bit from this, all of these different data applications that our customers and we ourselves at Astronomer build using the data that is funneled through these pipelines, that is not an easy thing to do. And why is it not an easy thing to do? Well, I think there are many reasons, of course. But when I try to boil it down, I think it comes down to this sort of artificial division or historical division that's come up between the three key players in the production of these applications. Starting from the right, there's the application developers themselves, of course, who are developing applications on your phone, on websites, on your desktop. You've got upstream of those, the data scientists who perhaps are publishing models and analytics that are used to build those applications. If you think of an application like Uber, for example, or Lyft, they're essentially completely powered by predictive and other models that govern the pricing, the arrival time of your driver, and so on. And those folks, in turn, rely on the data engineers who are providing them with fresh, recent, clean, reliable, safe data. And all of those teams tend to work, at least historically, in separate silos. The data engineers are writing SQL against their databases. The data scientists especially are sort of sequestered away in their notebooks, and the application developers are concentrating on their frameworks. And what I think we like to propose at Astronomer, and what is built in almost from the ground up with Airflow, is a production-first mindset. The lesson here is to take the lesson of those app developers. An app developer would never think to write his or her code in one architectural framework or one coding language and then move that into another in production. The code that they write at the time that they write it is the code that they expect to run into production. It's just a matter of DevOps to get that actually running. And the way that Airflow works is that you write your data pipelines, whether you're a data engineer or whether you're a data scientist, in a way that is comfortable for you, but in a way that can easily then be transferred into production. The code that you write in your notebook or the command line or your SQL is the code that runs in production. That is essentially what Airflow enables. So that production first, that orchestration first mindset is what I'm trying to suggest is key for the delivery of data applications. Good. Okay, well, let's get to some questions. Stephen, back to you.
Okay, we're going to dive into our group discussion, get everybody up on the screen here. So, Mark, I'm going to let you tackle our first question for today. And the question is, for an organization to fully unlock the power of modern data apps, what do you view as baseline requirements as far as the data stack? You know what? I think you're still on mute, Mark.
Thanks for shouting it out, Stephen.
No worries.
I made the first rookie mistake. Sad part is I'm not a rookie at this, so I should have known better. Anyway, but yeah, great question. We hear this kind of thing all the time, and any of my responses are always going to be through the lens of operational data processing. But for our customers, it really is about addressing core app requirements first, right? If apps need to work as fast as possible and be available all the time, then you can't use just any old database to meet those kinds of expectations. You really need to consider app users and where they are when they use the app. And if they're on a mobile device, will the app continue to work if they get on a plane or go into a subway and their network is no longer available? Because it turns out where you process data and AI for apps can have huge implications on user experience. So for our customers, really baseline requirements include making sure you have a database that works, not only in the cloud, because the cloud always is kind of a central control point for applications and it brings immense scale, but also be able to process data at the edge with synchronization between layers for consistency. And this way, those pesky things like internet disruptions don't impact the user's experience. It remains, fast and reliable wherever users go. So I think, when it comes to considering the data stack, always consider what your expectations for app, performance, availability, speed, all of these things, because the database will have direct implications on that.
Understood. Thanks, Mark. Artyom, I'm hearing database, data processing from Mark. What do you view as key baseline requirements?
I would kind of, since we sit in a little bit on later in a stack, I would say, right, I would focus on that part. I think kind of the data modeling piece and kind of making sure that everything is structured in a proper way with a proper governance. I think that might be a key to it. And when I say it, it's not only like semantic layer piece, right? It would be what's happening in your database, how you structure database, how you transform data, what is your data pipeline, and then finally how it comes down to the sort of like a semantic modeling, and then how that can be published and reused sort of like as a data app to let data consumers use it differently, right? So I think that sort of like area I would highlight here in addition.
Understood. Stephen, I know going last, they're taking hopefully not all the good choices, but what do you view as baseline requirements, any components you'd like to add here? Oh, I think you may be on mute as well.
You're absolutely right. Maybe stepping back a little bit, I would definitely emphasize transparency for sure. Stepping back, I think just broadly speaking, to me, the key requirements are reliability, scalability, transparency, and ease of use. It's perhaps not the highest priority because in the end, if something performs, if it scales, and if you have governance features around that, then maybe if it's a little harder for your developers, it's less important than if it's reliable and safe for your end users. But I, on the other hand, do think that you can't get real quality out of an application as it's easy for everybody in your company to come together around creating those. But still, transparency, reliability, scalability, with an emphasis on transparency, because I think once you have your data pipelines up and running and delivering results to end users, you need to be able to make sure that that is being done in a way that is safe and ethical and free of bias. And so being able to understand where the data comes from when you deliver that prediction or that metric or that result or that opinion to your end user on your platform, you better be damn sure that you know where that came from.
That's great, and totally agree with your point on ease of use. If people hate using your application or don't want to use it, or not enough people use it, obviously you're not getting as much value as you could be getting. So Artyom, I'm going to let you kick off our next question. The question is, how important are real-time capabilities? I understand this. The answer probably depends on who you ask, but curious what you're seeing in this area in general.
Yeah, I think that's a great question. I think many times I hear about real times. I always try to kind of get into details. What do we mean by real time, right? And it feels like in many, many cases, real time is really micro batching. Sometimes in rare use cases, we have a really streaming level, microseconds, seconds level of real time, right? So in that case, like that's a valid use case, and we need to think about, okay, we need to support the real time stack here and how we do that with the streaming technologies, and which is generally more expensive from an implementation perspective, from maintenance perspective, and frankly, even from like infrastructure perspective, it's just going to cost significantly more. And then in some cases, real time is really like 5 minutes, 10 minutes, 20 minutes, right? Like we can do micro batching here. So, and that's in many cases going to be significantly cheaper. So I think when we're thinking about real time before kind of, like go all in on some streaming technology and, like invest a lot of time and resources, I would always try to take a step back and understand, are we really solving streaming level real time here? And do we really need that? Is there a business case, business value for it to be like a seconds level? Or, like we can get away with like a 10 minutes micro batching and, like with building like incremental updates in our databases, like a data marts. So that's usually the first question I'm trying to understand. If it's truly streaming, then yes, but we all need to understand if we need to build a streaming level, that's going to be a long and probably expensive journey, because I'm a big believer in a lot of like modern streaming level technologies. I think there are like a lot of good alternatives to Kafka, like we can start to see it on the market right now, like which offer more like Kafka in Rust, Kafka in C++, very memory efficient. And then like a lot of interesting technologies on like a SQL over stream processing, but it's all still very early, and it's usually still very expensive from money and time perspective.
Understand. Yeah, and it does seem like there's real time and then there's real time, and it does seem like something it's shorthand for we'd like it fast and we don't really want to wait around. Stephen, I'm going to let you tackle this next. Would love your viewpoints, what you're seeing at Astronomer.
Yeah, I think I see it rather similarly to Artyom. Certainly at Astronomer, when we get asked about real time, which happens quite frequently, we usually dig into really what the requirement is there as opposed to what the technology is. Airflow arguably is mostly focused on batch processing of data, although it certainly has connectors to Kafka and other streams and so on. But in most cases, what that reduces down to, as Artyom's saying, is micro batches. Arguably, streaming is just micro batches where the batch size equals 1. So I think it's possible to focus instead on what the requirement is. And usually it's about real-time decision-making as opposed to a specific technical requirement. And what that means can be very different from a board real-time decision to how the market is reacting to your application. The board is going to want to respond to that in real time. But that is something very different from how your site reliability engineers are going to want to react in real time to a fault in your application. So really the choice of technology should be dictated by what the actual requirement is. But there is no doubt that more and more companies want to have real-time decision-making. And that means the delivery of accurate data to the point of decision-making very, very quickly. But that doesn't always necessarily mean seconds.
Understood. Mark, would love your take on this. I know this is probably near and dear to your heart.
Sure. I mean, and 100% agreed with exactly what Artyom and Stephen were saying. 100% agreed. And real-time capabilities. I come from a not just database but analytics background and BI, and real-time information is kind of this overarching goal that has been around for years. Everybody wants it, but it really is. You need to define, what do you mean by real time? Is a few seconds latency acceptable, or a few minutes, or does it actually need to be as things occur? So different applications would yield different answers. But really around where I'm seeing this in operational analytics, it's around being able to take action quicker, right? Being able to capture and reflect data changes as close to when they occur means you can react quicker and take action. And it's really important for AI as well. Real-time information can help AI, like LLMs, engage in context with current data better. But getting data in real time is also that long-standing traditional challenge, especially when you consider a sprawl of multiple databases that's so common in many enterprises today. And at Couchbase, we've really tried to address this, well, in multiple ways, but the two that come to mind. First, by processing data at the edge on device, you're going to really start to reduce latency. And when you process data on the device itself, you can gain sub-millisecond performance for on-device apps. And that's all around just eliminating the need to go through the internet for data. You're eliminating hops and latency incurred therein. But second, another that comes to mind is our columnar analytics service is able to source data via Kafka streaming. Kafka has come up a couple of times in the conversation. Where it needs to be reflected as it occurs, that's where streaming comes in. And so our ability to do this allows us to pass data from sources as those changes occur, and it allows analysts to see them in real time and then take action. And we tried to even go one more above that. Our columnar service can write back analysis results to the operational database, where it can be used to tackle action immediately. So, real time is important. Define what you actually consider real time, of course, before you endeavor to try and enable it. But we're really trying to do our best to address it for our customers and their requirements.
Understood. I think it's time to dive into our next question. Stephen, I'm going to give you first crack at this. Do you need a fully integrated data management layer to be successful here?
That's an interesting question. I guess I mean, yes, is the simple answer. I think that as I was sort of indicating in my discussion up front, it's these silos of development that I think often get in the way of doing sort of efficient data-driven application development. You can't have data applications unless you have a clear path from your sources of data through to data processing, whether that's ETL or model processing, feature generation, and so on, through to your application. So often that means you need to have a lot of different components working in concert with one another, from your relational databases to your data scientist notebooks to your Spark clusters to your application frameworks. So I almost don't. I can't imagine how anybody would defend saying no to that question. Of course, it needs to be integrated, because otherwise you're just constantly running into manual processes for taking the output of one team's work and applying that to what you need in your application. Yeah, I think an integrated stack is important, especially for what I was talking about earlier with transparency. If you have a separation of concerns from in terms of which teams are doing what, that's totally fine. But if you have a separation of technology, so that there are real sort of walls between what your data teams are doing and what your application developers are doing, then I think you're likely to run into real trouble, because you don't know exactly what it is that your application is relying on to produce the results that it does. Integration is key for me. Yeah.
Understood. Mark, what's your take? Are you going to tell us no?
I'm not going to be the one to say no here. I agreed with Stephen. I mean, Couchbase can fit into a data management layer as an operational data source. This is where we typically run into it. We see this, for example, when Couchbase is part of a data mesh architecture ecosystem. And in these cases, our columnar analytics is typically employed to serve and feed the architecture with real-time operational analytics results, in addition to the raw operational data itself. So agreed. I think the bigger the organization, the more important it is to have an integration layer and a clear plan for how things map. Couchbase can help simplify the underlying operational infrastructure, of course, for the points that I made earlier. But yes, agreed with Stephen. I think it's a good idea for the larger organizations, especially.
Understood. Artyom, anything you'd like to add?
I would agree that integrated data stack makes sense, but it will also highlight that I don't think it should be coupled or it should be monolithic stack. I believe it's good to have a diverse set of different tools that do different job, but they need to be able to integrate together and map nicely and just kind of somehow being orchestrated correctly to be efficient. And like in software engineering, like we had the age where we had monolith applications, and then we kind of moved to microservices architecture. And it's hard to manage it, but then we got Kubernetes, which made it much easier, right? You have a lot of different services, but you kind of have this orchestration layer where you can sort of like integrate everything and manage it. I think from a data standpoint perspective, I don't want to go back to like days of like a monolith application and a single vendor that sells you everything. I don't think it's efficient, because from a process perspective, this teams, especially in larger organizations, it would be good to have teams that can have a separate set of technologies and they can really move faster because of that. But at the same time, they can be integrated into the larger picture of the organization, right? So I would advocate for smaller teams that can move faster with their technologies, but at the same time, everything should kind of roll up and integrate nicely together.
Understood. Well, I'm going to let you kick off our next question, Artyom. Building modern data apps is about technology, but it's also about people. What is the ideal team and mix of skills?
Yeah, I think it would really depend on, like what kind of problems we want to solve here and what kind of data apps we need to build, what kind of data experiences we need to support. I believe that, like the data stack is sort of like clear at this point, the modern data stack. You have a low level like data engineering skills, right? You need to run and manage your transformation, ingestion, cloud data warehouse. And then on top of that, you need to provide insights to the data consumers, to the stakeholder, right? Like either as reports or ready to use data models. And somewhere in between the transformation and data modeling happening, and that's where you also need to understand a lot of like domain, right? If you support finance, you probably need to understand like that domain. If you support product marketing, you would need to dig deeper into that domain. So it's always a conversation with a data person and the sort of like a data consumers, what kind of data modeling we do. Because at the end of the day, data modeling is a reflection of a business process, right? Like we describe what's happening within an organization and we model it as a set of like a SQL script, so like a specific like rules to transform and model data. But we need to understand the business process first. So I think it's good to have embedded teams into specific departments where we need to support them that can gather, collect, and kind of retain this domain knowledge and be really like spend a lot of time in understanding the business process, how Salesforce is being managed, like why is this things done in Salesforce the way it's done. So then later they can have this knowledge and can be able to build all this into the reporting, right? And then at the same time, some sort of like a central data governance team that can control the foundation. And then once you have embedded team and a central team in combination, I think they can deliver really good results, assuming you have a really good process and a technology in place.
Understood. Thanks, Artyom. Okay, Stephen, what is your view on this question? Ideal team and mix of skills.
Yeah. So, everybody knows what a good team looks like for developing a general application. You have your platform and application developers surrounded by a customer or product manager who's guiding their development, and then QA engineers and so on. Into that, you need to inject people who have particular expertise around the marshaling of data to supply your application. And those typically are going to be data engineers, machine learning engineers, maybe the data scientists to create the models in the first place if you're relying on sort of predictive models. This seems like an obvious thing, right? Is that you join to your application developers folks who are specialized in the production nature of running data pipelines. But I've heard people sort of negate this and say, well, now in the days of generative AI and freely available models, the application developers can just use that stuff themselves. They can just pick off the shelf their large language model of choice or their machine learning sentiment analysis model of choice from one of the cloud providers, and you're good to go. And I think that's unwise. I understand that sentiment. It simplifies things arguably, and it is true that models becoming much more tailored and sort of ready to wear. But in my own experience of developing applications with machine learning models and with generative AI especially, it's very easy to fall into a trap there. The models are so easy to use that you feel like you can just plug those into your application and you're ready to go. But in fact, you need very strict adherence to principles and best practices around quality. You need very careful and sensitive prompt engineering and additional techniques to get the most out of large language models for generative AI applications. And I found that often the skills that have been built up over years in the developing of traditional machine learning, such as a sensitivity to feature creation and an understanding of statistical tests and how to validate the quality of models, and how to do that in production, being able to do champion challenger and so on, and being able to introduce new models and monitor them carefully. These are all key skills that you don't just get for free. So it's very important to have your machine learning engineers, your data engineers who understand how to bring data and models to production.
That's a great point. It sounds a little bit like a mirage, like, oh, this is really easy to use. We can just plug this in right away, but use effectively and responsibly. It's a different story. Mark, anything you'd like to add?
I mean, just that I 100% agree with my co-panelists. Caltrace is really focused on developers, right? Making them more productive and making their lives easier is sort of in our DNA. But app dev also requires architects who understand the implications of deployment choices. And Stephen mentioned it. You need skills in things like data science and model training. Also, business analysts are required for measuring successes and discovering areas that are in need of attention, within operational systems. And so, really, all of my recommended resources are, of course, tied to the data processing side of things. But again, considering data, how you handle it is where you can set the foundation for the success of a given application. So having strong data-focused resources is really important.
Understood. Stephen, we're going to let you take the next question here. What do you view as the top reasons these types of projects fail or end up delivering limited value?
Sometimes I think people can get overambitious around building applications around data and analytics. It's important, and I'll bring it back to generative AI again, it's important to recognize, where am I actually going to get real ROI from these models? What are actually important business problems to solve? So many of us are being told, do something with AI, do something with machine learning. That's been true for a long time. I think it's especially true now. And it's important for everybody to calm down and say, well, look, what are actually the major business problems that we have to solve? What are the challenges facing the organization? And how can AI be brought to bear on that? I'll also mention what I mentioned right at the top, which is this production-first mindset. I think data scientists and data engineers and so on often operate within these silos. They don't necessarily think about, once I've built this analytic, once I've built this metric, once I've built this model, how do I actually run that in production? Is this going to scale? This uses data that may not even be available to the application within her particular ecosystem or technical environment. So that production-first mindset and making sure that you have tools to use to build your development that are then ready to be productionized is really sort of fundamental to what we at Astronomer do. We essentially create this conveyor belt that allows you to do all of your work that you would typically do as a data team and as an application team. But then you just hit a button and now it is running in production, right? That's very simple to say, but is oh so important and so often forgotten, is that let's follow the best practices of the application developers. Yet let's use orchestration frameworks like Airflow to build in production level practices right from the beginning.
I think that's great advice. Mark, would love your take on this. Biggest reasons, biggest roadblocks or obstacles or reasons these projects just don't work out.
I've seen my fair share of project successes and ones that might not have gone so well throughout my career. And in my experience, app projects that fail typically start with a failure to get buy-in first at the top. The mistaken approach instead is to first, let's get a few successes and then approach upper management with all these stellar results. And then this kind of leads to this mad rush to see positive results, without considering things like, the state of your data, its cleanliness and your ability to access in a timely manner and ability to, govern access. And when problems arise, upper management then finds out and are much less apt to endorse a given app effort. And that can lead to abandoned initiatives, wasted time, and wasted effort. So by, getting sort of organizational buy-in first, then approaching the project in a really measured and careful way to ensure the integrity of the data and map it all out in advance, you can better set yourself up for a successful application delivery.
Thanks, Mark. Artyom, what do you see in your experience?
I would highlight the control of the scope of the project and a timeline at the same time. I think Stephen mentioned that sometimes projects can get overambitious and, that can kill them. I think that's part the scope, right? So I think we really need to understand.
Oops, it looks like we lost Artyom there. Hopefully he can get back on with us quickly. I think looking at the clock here,
Time kills deals. So that same true is for project management in general and kind of software engineering, data engineering. So we don't want to be over kind of spending too much time on specific topic on a specific project without unclear scope. So balancing scope and timeline, that can lead to success. If we either do not have a clear scope but do not have a clear timeline, the project most likely going to fail.
That's a great point. I'm looking at the clock here, and we're almost at the top of the hour. I think we've got time for one more question, and it's a question I'm going to ask to each of you from me. If there is one thing you would really like our attendees today to walk away keeping in mind, what would that be? And Artyom, why don't we start with you? You know what? I'm not hearing you. Are you on mute by chance? Oh, it looks like he might be frozen. Mark, why don't we move on to you on that question?
Sure. I'm kind of going to be parroting themes that I've been talking about throughout, but really consider your appetite for building an app that is slow and unreliable. In most cases, when you consider that, there is very little tolerance, in fact, for slow, unreliable apps. In fact, that's one of the top reasons that people will abandon an application. If it fails to load, if it crashes just 2 times, abandonment just goes through the roof. So consider those things first, and then consider how do you ensure a fast, reliable experience for your app users, and how can data play a role in that. And this eventually, should lead to looking into a data infrastructure that can contend with network problems and latency and users at the edge. So this is a very key problem that we solve for our customers who require their apps to be 100% available, 100% uptime, and as close to real-time speed as humanly possible. So really, I think hopefully that the takeaway there is consider your app requirements and how the data can help facilitate that.
Thanks, Mark. Artyom, can you hear me?
I can hear you now, right? I think I had some internet connection issue for maybe a few seconds, but it's all back.
No worries. Yeah, I wanted to make sure you had a chance to weigh in. So if there's one thing you'd really like our viewers today to walk away keeping in mind, what would that be?
Oh, yeah. I think, and the topic of this conversation is building modern data apps, right? So I'm thinking that when approaching building modern data apps and in general approaching data, I would say, and I would always recommend, try to apply as many software engineering best practices to kind of building data apps as possible, right? Because I feel like data somewhat lagging here as an industry to the best practices. So if we would even look at DevOps, I think they did it a little earlier with all this movement around DevOps and kind of, bringing all the modern operations infrastructure. And at data, I think it's happening right now as part of the data stack. So I always try to advocate for if we're building some data app or data project in general, let's treat it as a software project, right? And apply software management principles, software development principle, testing, staging, version control, continuous delivery to the just building data apps in general. So that would be my one advice.
That's great advice. And last but not least, Stephen, if there's one thing you'd really like to leave our viewers with today, keeping in mind the most.
Yeah, I'll keep it super brief because we're running out of time. I'll quote the great English novelist E.M. Forster, who said, "Only connect." So get everybody to talk to each other, get everything connected for the reasons that I mentioned before about making sure that it's easy to bring things to production so that everything's connected in single connected pipelines. but also after the event for governance, for transparency, for visibility, for observability, making sure that everything is integrated together. That's the key.
Thank you very much, Steve. And thank you, everyone, for joining this event today and staying with us. I know there were a number of questions we were unable to get to. I am going to share those, of course, with Mark and Artyom and Stephen offline so they can follow up as appropriate. I'd like to give a huge thank you to our speakers today. Once again, Mark Gamble, Director of Product and Solutions Marketing at Couchbase, Artyom Kidinov, CEO and co-founder of Cube, and Stephen Hillian, SVP of Data and AI at Astronomer. If you in attendance would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. This will be archived, and you will receive an email from us once the archive is posted. Thank you, everyone, for joining us, and we hope to see you again soon.